So welcome everyone today to the Federal Leadership and Professional Development Seminar Series. This is our 11th seminar. Just as a disclaimer, no statement in the seminar should be construed as an official position of AHRQ, HHS, or any other federal agency. So what is the Federal Leadership and Professional Development Seminar Series? It's a cross-government seminar series on leadership and professional development topics, with seminars occurring every 1 to 2 months. The speakers are federal employees, most are SES or other leadership roles, and attendees can be any government employee, any GS level. Attendance is in-person or remote. There's no cost to attendees, and the seminar series is not funded. There are 3 main goals for the seminar series. One is to share federal leader expertise and lessons learned. 2, provide free trainings, as training resources are always limited. And 3, bring individuals together and foster intra and also inter-agency connections, collaborations, and sharing. So it's proven to be a very effective mechanism to share federal leader expertise, and folks have found it very valuable to have feds actually talking about leadership in the government. The seminar reach is government-wide. Right now, we have about 3,200 subscribers on the listserv, and it's continuing to grow. Our new development, our exciting new announcement, is that we're going to be creating a member database. So if folks that are on the listserv would like to be included in the member database, I'll be sending out a survey in January. And if you would like to be included in the member database, that you can be contacted by other members if folks want to connect with you. Then please do fill out the following fields: name and contact information, et cetera. You can also include expertise. This is completely voluntary. It's just a way to facilitate connection between the members of the listserv. So whoever does opt to join the member database, then we'll send out the spreadsheet of the database in February. In that same survey that I'll send out in January, I'll also include opportunities for involvement, volunteer opportunities to be involved in, suggesting future topics, speakers, etc. So for the lessons learned today, just be thinking during the seminar what your biggest lessons learned are, and at the end of the seminar, you'll be receiving a post-seminar evaluation survey that will ask you about your biggest lesson learned, and then also what you plan to do with it. And if you're in the room, folks have leaves in front of them. If you write down your lesson learned, then it'll be added to our big 7-foot tall tree of learning. Our next seminar is coming up in February. The seminar will be on life balance for leaders. We also have seminars coming up on professional branding and also best practices in strategic planning. So for more information about the series, please don't hesitate to contact me. Here's information about joining the listserv if you're not on the listserv currently to receive future announcements. And also the link to the YouTube channel is here as well. The YouTube channel has recordings of all the seminars since February. Michael Bostrom is joining us today. He is the Installation Readiness Program Manager and the Continuous Performance Improvement Program Manager for the Marine Corps Installations Command. Marine Corps Installations Command is the headquarters command for all Marine Corps bases around the world. Michael began his federal career in 1987 as an enlisted Marine and was selected for the Marine Corps Enlisted Commissioning Education Program. After obtaining his degree in Business Administration and Finance at Oregon State University, Michael was commissioned as a second lieutenant in the U.S. Marine Corps. Michael served as a comptroller and active duty Marine for 12 years before transitioning to the public sector. He started his performance and process improvement career in 1999 when he joined KPMG Consulting as a senior analyst in the Federal Services Branch, conducting business process improvement and re-engineering projects aboard Navy and Marine Corps installations. In December of 2000, Michael transitioned back to the Federal Service as a senior management analyst at the Business Performance Office at Marine Corps Installation West, Marine Corps Base Camp in Pendleton. He served 15 years there before accepting his current position with Marine Corps Installations Command at the Pentagon. Michael is a certified Lean Six Sigma Master Black Belt and a certified Yellow Belt and Green Belt senior instructor and a member of the Federal Improvement Team. Michael joins us from the Mount Pleasant neighborhood in DC and is originally from Boise, Idaho. Please welcome Michael.
Thank you, Kim. First off, I'd like to thank Kim for having me here today to speak with each of you, and also each of you for attending. Today we're going to be talking about continuous process or performance improvement, how to use Lean Six Sigma and theory constraints to improve the performance in your organizations. So before we get started, I'd like to ask a question and have each of you indicate whether you know of or whether your agency has a has a performance process improvement program within your organization? So indicate please yes, no, or don't know. We'll be coming back to that data here at the end of the program. Okay. So again, we're going to be talking about three methodologies within what we call the CPI, or continuous performance. Sometimes you'll hear that referred to as either continuous process improvement or continuous performance improvement. It's a little term that DoD came up with in order to encompass the three methodologies of Lean, Six Sigma, and theory constraints. We'll be talking about each of those. We'll have a little bit of a summary towards the end and provide you some additional resources as well as an exercise. The graphic that you see up here on slide 4 illustrates that CPI, again, is a term developed by the DoD used to refer to the three methodologies of Lean, theory constraints, and Six Sigma. So what is Lean? Real quickly, Lean is where we eliminate non-value-added activities or waste within our processes. Theory constraints. With theory constraints, we're focused on identifying and mitigating constraints within our processes. And Six Sigma, the focus is reducing process variation and improving reliability. So again, we chose CPI to be the encompassing term for these three methodologies. All three methodologies are very complementary, and we'll see that as we touch on each of these today. Okay, so first we're going to talk about Lean. So what's Lean? So the textbook definition is Lean is a set of principles, concepts, and techniques designed as a relentless pursuit to reduce waste. In layman's terms, what that means is we're just removing as much waste from our process as possible. We'll talk about the different types of waste here in just a minute. But keep in mind that the traditional focus used to be on trying to improve the portion of our process that was considered value added. And if you take a look at the graphic there at the bottom of the slide, traditionally about 5% of our processes is what we consider to be value added, whereas 95% is what we consider to be non-value added or waste. So with Lean, we're trying to reduce that 95% portion of the pie as much as possible. If we do that and remove waste from our process gets faster and less expensive, or we save money. So thereby, Lean is about speed and efficiency. Toyota Production System, or TPS, they're the gold standard in Lean production. Again, a typical process efficiency is about 5 to 10%. Using Lean religiously boosts out to about 20 to 25%. So with that, the next slide, so what is its purpose? Again, Lean is about removing waste or those activities that don't add value to our processes or the performance of our organizations. You'll hear me use the term synonymously, but non-value added is the same as waste. We'll talk about each of the wastes here in just 1 minute. When you're analyzing your process, oftentimes you'll see a red dot, and that is used to symbolize the waste or the non-value added portions of your process or steps within your process. Okay, so what is waste? So we have eight types of waste. The eighth one is complements of DoD. We added the eighth one, trying to make it our own. But the first 7, you'll more than likely hear in industry. The first type of waste is transportation. The second is inventory or excess inventory. Third is motion. Fourth is waiting. Fifth is overproduction, overprocessing, and defects. And as you see up there at the top of the slide, there's an acronym that can help you remember that, TIM-WOOD or TIM-WOOD-U, depending on which version you're going with. But anytime you see that 8 types of waste within your process, we're going to label that as non-value added or waste, and we'll usually put a red dot on it to signify that that process step is non-value added. Keep in mind that the coding of those process steps as waste, it simply gives us a way to focus our efforts so that we can come back and reduce those as much as possible in the future. So a little bit about Lean and the history of Lean. Lean is the oldest of the 3 methodologies, and it dates back to the early 1900s with Henry Ford being one of the first people to declare what we call a war on waste. Henry Ford worked vigorously to remove the waste in his processes associated with the assembly line and the building of the Model T. By doing so, he realized significant reduction in both the cost and the time required to produce the Model T. One of the things Mr. Ford wanted to do was to get the new technology into as many people's hands as possible because he knew it was life-changing. And the only way he could do that was to reduce the cost. And when you reduce the cost, you then need more people are able to afford the vehicle or that product, and then therefore you're going to have to increase your production. And he was able to achieve both of those goals using lean concepts and the lean methodology. In the 1940s, after World War II or towards the end of World War II, the United States took lean back over to Japan in order to build up their manufacturing capability. The Japanese, of course, were very susceptible to lean and really took it and ran with it. And so much so that the United States basically more or less had lost the practice or the utilization of lean manufacturing concepts until James Womack from MIT brought them back to the United States many years later. So lean started off here in the United States way back in the early 1900s. We took it over to Japan to help rebuild them after the war and kind of forgot about them, for lack of a better term. And then James Womack brought that back for us and developed what we call 5 lean principles. So that's basically how you do lean is with the 5 lean principles. So the first lean principle is to specify value from the customer's perspective. Keep in mind that the customer is the ultimate determinant of quality within your process or value within your process. And so when you look at leaning out your process, you want to make sure that you specify that value from the customer's perspective. The second lean principle from James Womack is to identify the value stream. Value stream defined is simply everything it takes to produce a product or service from the time the requirement is identified until that product or service is delivered to the end user. That constitutes our value stream. And so, as you can imagine, that can be quite a large process. And so, what you want to do is you want to keep in mind that you want to focus on improving the system as a whole and not the individual parts of that. And so, in order to do that, you have to identify the entire value stream. The third lean principle is to make value flow continuously without interruptions. Very similar to the example of the assembly line, where the vehicle is moving throughout the process and continually adding value at each step in the process. Same with lean principles. You want to make sure that that value flows continuously and that there aren't interruptions in that process. Step 4, the fourth lean principle is to let customers pull value, produce only what the customer requires or pulls out of the process. This is going to make sure that we tie production to customer demand. Going back to one of our types of waste, overproduction, this ensures that we don't enter a situation where we're overproducing. And then step 5, relentlessly pursue perfection. We need to continuously assess our process and its performance and establish that culture of continuous improvement, which is what the C in CPI is all about, that continuous process or performance improvement. Okay, some of the tools that we're going to talk about for under the lean methodology. The first one basically deals with cell layout or workplace layout, whether you're laying it out for your process or for your organization. But traditionally, on the left-hand side of the slide, you see what we call the before, but the process is confusing. There's a lot of travel and motion waste within the process. If we have something that's at the install phase, we're not sure whether that's at the beginning of the process, at the end, how far that product has to go until it's complete. And so there's just a lot of waste that's inherent with this type of setup. And so what we want to do is we want to move towards something more like what you see on the right-hand side of the slide, where it resembles basically a horseshoe scenario. So the product or service is inducted at the top of the slide. It goes through, works its way throughout the process, and comes out the bottom of the horseshoe. If we do that, then this is what we call single piece flow, where we produce one at a time. It's very visual, so if you can stand anywhere in that process and tell the status of the process. You can tell where that part is in the process. whether it has 50% to go, whether it's about complete, or whether it's just beginning or entering that process. And it also reduces travel and motion waste within your process and your organization. The next tool we're going to take a look at real quick is something called a spaghetti diagram. And I guess I can probably give you 2 guesses as to why it might be called that. But it kind of looks like, maybe somebody dumped their bowl of spaghetti out on the floor, the one on the left. So a spaghetti chart or spaghetti diagram shows the physical layout of the production area. And so that's kind of what you see here on the left. And there's 2 different things that we're tracking there on the before side, material and technician. So if you take a look there, I mean, you really don't even have to know what the process is to know that, it's pretty busy, right? Probably that technician, when he goes home at night, probably put some miles on his tennis shoes. Now afterwards, what we try to do is, again, take a look at how that production area is laid out. And we try to lean it out so that we're reducing the motion waste, we're reducing the travel within that process. And what you see is just a lot cleaner process. So again, we don't even have to know what these processes are to know that, the one on the right is probably the better process, especially if you're that technician that's, putting all those miles on his shoes every day. And probably it's very minimal effort to actually achieve what was done on the right. Probably just some moving around of the different sections within that process. So again, this is called a spaghetti chart, and it shows the physical layout. Another tool you can take a look at is something called a circle diagram. Looks a little bit like grandma's needlepoint, right? So on the left there, we have the before. And basically what a circle diagram shows is information flow. It could be physical information flow, it could be virtual, whether you're hand carrying a document. I hate to admit it, but we still do that a little bit in the DoD. We've gotten a little bit better over the years, but there's some diehards that still want to have that physical document that gets carried from office to office for signatures, or for approvals, or for review. But you can also use it for virtual tracking of documents. And it basically shows all the handoffs that's going to make within that process. So again, you really don't even have to know what the process is to know that probably the one on the right is a lot better, right? With a lot of that waste removed, now it's going to be, not only faster, but probably, if you're not tying up all those people's time, taking a look at whatever we're routing through that process, then, it's going to reduce the cost of that process as well. So again, all these tools are aimed at trying to lean out your process and, whether it be the physical layout of the process or the virtual layout of that process, and to make sure that we address each of those types of waste and reduce them as much as possible. Another tool that we have within Lean is something called a 5S. And the 5S is a workplace organization tool. I hate to say it, but it's kind of like cleaning out your garage. I'm always surprised at the level of interest when I teach Greenbelt that people have in doing a 5S. And if you do it properly, it's quite a bit more than cleaning out your garage. It's putting controls in place so that your garage doesn't go back to what it looked like before you started cleaning it up, which we all know that happens pretty quickly. But it's a process and method for creating and maintaining an organized, clean, and high-performance workplace. And again, it helps to create that visual workplace so that you can tell where things are at in the process, you can tell what the process is, etc. It helps people distinguish between normal and abnormal conditions at a glance. If you've gotten rid of all the clutter in your process, you're now able to see whether the process is on track, whether they're behind. You can make it visual. A lot of the DMVs have started going with the Qmatic systems and those visual systems. People can distinguish between what kind of conditions they're having there. If the Qmatic's on D400, you've got D1, you're probably going to be there a little while, right? But at least you know what the process is and you know where you're at in that process. 5S, we consider it to be a foundation for continuous improvement. Trying to achieve that 0 defects, reducing costs, and then just having an overall more productive workspace. And if anybody's ever seen that show Porters, it's on cable. They do something very similar in that program where they go in and the first S there, they sort. They go through and they sort the needed from the unneeded. It's So you clearly distinguish needed items from the unneeded, and then you want to get rid of the stuff that's not needed, right? The hoarders usually want to keep it, but luckily they have somebody there that kind of convinces them to do away with that. And keep in mind that this can be applied to both a physical and a virtual environment. So you can apply this to not only your shared drives, your SharePoint, your calendars, et cetera, your hard drives for your personal computers, in order to get the full effect from a 5S within an organization. So the first S then is sort. Second is to simplify. You want to keep the needed items in the right place. Example of this might be if you use file folders in your job or in your workplace, you probably don't need the whole case of them right there at your desk, right? You probably need a few there, or however many, enough to get you by for a month or a week or whatever the case may be, and probably the rest are somewhere else. So again, so that you don't have all that clutter within your work section. So again, keeping the needed items in the correct place to allow for easy and immediate retrieval. And you'll hear this from time to time, but we call it a place for everything and everything in its place. So the third S is systematic cleaning. It goes a little bit beyond just cleaning up your organization or your workplace or your garage, whatever the case may be. It's also doing some of that maintenance that needs to be done. Making sure that the filters are clean, the preventive maintenance is done in those machines. And again, keep in mind that it can be applied to either a physical or virtual environment. The fourth S is to standardize. So you find the best way for using subject matter experts from that work section to find the best locations, the best methods, et cetera, and then those become the new way. So if you've designed the office to be a certain way, according to your subject matter experts within your organization, and you've designed the layout and where things are going to go, and a place for everything and everything in its place, then that becomes the new way. And everybody has to buy into that. And we have tools like standard work instructions and SOPs that help us keep it that way. And then the last S is sustain. So just like in our home lives with our garages, we need to be able to have the discipline to maintain those improvements because people have, it's just human nature that people want to go back to the way that the previous or the status quo. But if we don't have that sustain or that discipline to maintain the first four S's, then we'll quickly find ourselves back in that situation that we were at before. Same thing with the show the hoarders, that show on the hoarders. Okay, so when we talk about lean, and we've talked about the non-value added part or the waste, but there's also the value added part. And we have some very specific definition of what's considered value added in your process. So when you're taking a look at your process and you're looking at removing the waste and going in and labeling things as value added, non-value added, et cetera, in order to be considered value added, it has to meet these three criteria. The first one is the customer has to want it, of course, and therefore, by extension, be willing to pay for it. So when I teach green, I always like to use the analogy of a steering wheel on a car. Does the customer want a steering wheel on a car? Yes, right? So they're willing to pay for that. Maybe they want a driverless car or something, but they want that vehicle to be able to steer in some form or fashion. The second condition is that it has to change form, fit, or function. So currently, if I don't put a steering wheel on a car, does it change the form, fit, or function of that product? Yeah, because then you can't drive it, right? Under current. Now, I'm going to have to change my example probably here in the next few years, but yeah, so that's kind of the litmus test for changing form, fit, or function is that it has to change some sort of aspect of that product or service. And then the third criteria is that it has to be done right the first time. It can't be a product of a rework loop or of rework itself. So if a process step meets those three conditions, then we consider it to be value added and we put a green dot on it. And again, we're not going to look at the value added stuff. That was a traditional focus. Now we're going to focus our efforts on the non-value added parts of our process. All this, the coding of each of those process steps is something called it's all part of something called a value analysis. You're taking a look at each step in your process. You're going through those criteria that I talked about before for, you're looking for the Tim would or Tim would you, making all of those with a red dot. You're looking at the value added, checking out those 3 criteria, putting a green dot on those. Or you may have something that doesn't neatly fit within those 2 categories, and we call that business value. In business value, usually process steps that can't be changed due to current laws or technology. You'll hear a couple other definitions for this. This is the one I tend to like. It's usually stuff that the business requires you to do, especially in my line of work. Granted, where I work at for Installations Command, we're the headquarters element for our installations around the world. So, there's a lot of things that a headquarters usually requires of their subordinates that they have to do, right? And so that's the type of stuff that would fall under business value. Or maybe if I'm at a facilities maintenance organization on one of our bases, we have to abide by water quality regulations and those sorts of things. So again, those are current laws and technology that we can't change and that we have to abide by. Again, we use this value analysis as a way to focus our efforts. So that anything that we put a yellow or red dot, we're going to look to remove as much of it as possible, or reduce it as much as possible. Okay, so some best practices for lean. We always encourage people, if you do nothing else other than map your process and remove the waste, you'll be doing better than probably 90% of the organizations out there. And it's not that hard to map. You'd be surprised at how many people really don't even know the process or some of the processes within their organization, or they're unfamiliar with, well, what happens with it when when it leaves my area, or I throw it over to the wall in the next step in the process. Most people are usually just focused on their little piece of the pie or their little piece of the process. So a best practice then would be to, at least map your process, make that available or make it visible so that not only your customers know what that looks like, but the rest of your organization. And then conduct kind of what we just did, a value analysis. Go through and take a look at, what things are considered to be waste. What motion do I have in my process? What transportation? Where am I overproducing or where am I overprocessing? And label those. Label your value added based on the 3 criteria we talked about, your business value. And then try to remove as much of those as possible. And it's surprisingly easy to actually remove the waste from your process. Once you've done that, you would create what we call a future state map, which is basically what your process now looks like with that waste removed. And then hopefully you get towards one of the harder parts of CPI, which is actually implementing things or implementing the new process. And then you want to make sure that you come up with some sort of control plan to make sure that your process doesn't go back to how it used to be. Because again, we're creatures of habit, and we tend to want to go back to the status quo or the way it used to be. Here's some examples of industry leaders in lean. And again, Toyota, no surprises up there at number 1. You'll see at the bottom of the slide here, that's just the reference where this was, I basically just did a Google search to see, what would come up. So again, no surprise that Toyota and Ford would be up there towards the top of the list. Some of those other, looks like there's a couple that aren't maybe real well known, but again, leading industries or leaders in their industry for lean manufacturing or lean production. Okay, a little knowledge check to see if everybody's still awake here. So what's the correct answer here? So lean is it A, a new weight loss program for employees? B, a war on waste? C, reducing the number of employees in an organization? Or D, adding what everybody loves, extra inspections? B, right? Yeah, it's a war on waste. B and DOD, I guess we probably had to work the word war in there somehow. But yeah, it's a war on waste, right? We're declaring a war on all those things that are causing our process to cost more or to increase our cycle time. Okay, so that's lean in a nutshell. Again, there's a whole bunch more tools that we haven't covered, but now we're going to move on to theory constraints. So again, theory constraints is focused on systems. It's basically follows the analogy of you're only as strong as like a chain is only as strong as the weakest link. Same thing within theory constraints. The purpose of theory constraints is to identify where that constraint is at and try to mitigate it. So a constraint can be anything that keeps you from meeting your goal. So the first step kind of there is to have a goal for your process, your organization. And then if there's things that are keeping you from meeting it, you probably have a constraint within your process. It's also referred to as the slowest step in the process. And so we pretty much always have a slowest step in our process, but it doesn't become an issue unless it's keeping us from meeting that goal that we've identified. It helps us understand interdependencies in complex systems. A lot of times things have to be done in a sequential order or a certain order, so it helps us to understand what those interdependencies are, and then it helps us align our practices and our behaviors towards the goals of the organization in support of reducing that constraint. Theory of constraints came from a gentleman by the name of Dr. Eliyahu Goldratt, who was an Israeli physicist. And it was based on, or he published his work in a fictional book called The Goal. Has anybody seen The Goal here online? Well, I say seen, but there's a book and there's also a movie. If the book's any good, they always make a movie, right? Same case here, but it's been a bestseller for many years, a business bestseller. But in the book, it's a fictional story that takes place where he actually describes what are called his 5 focusing steps. So the first focusing step is to identify the system's constraint. So we need to know where that constraint is at in our system. And the way we do that is we just visually look for what we call work in process. You can do this on your way into work in the mornings. When I used to drive into a base at Camp Pendleton in California, the WIP is going to be the number of cars, in the queue. So depending, you can see what your constraint is, whether it's a certain gate at the base. If you're at the grocery store, it could be a certain checkout stand. But your constraint then is going to be that one that has the most work in process or the most things that are being worked on. Maybe the most stuff in the inbox. So you identify the constraint, and then we have to figure out how are we going to exploit that system's constraint. At this point, we don't want to put any resources towards it, but we're going to try to get as much as we can out of the constraint without adding those resources. So whether to improve the efficiency of a machine, of a person, so that they're able to process something faster, we exploit it. The third step is we subordinate or we synchronize everything else to the constraint. And we do that because if we have various steps in our process and our constraint is only able to produce at a certain speed, if the others are able to produce faster, then what's going to happen? They're going to be producing faster than the constraint, and stuff's just going to be piling up. So again, it goes back to that overproduction that we talked about under lean. So what we want to do is we want to subordinate or synchronize everything else so that they're only producing as fast as that slowest step in our process. And so then that slowest step then controls the output of our entire organization. Step 4 is we would elevate, if we need to get to that point, we would elevate the system constraint by applying additional resources. Maybe we need another machine, another worker, another shift, whatever the case may be. And then at this point, if we're still not meeting our goal, we would reevaluate and see whether we're meeting our goal. And if not, then we would go back to step 1 because we probably still have a constraint somewhere within our system. So just a real quick example that kind of shows what we're talking about here. So this is an actual situation. I used to have to come to the naval station at Fallbrook every day on my way to work. But our constraint in this scenario was at the entry gate, they had 2 guards that would be there checking IDs every morning. And they did a 100% ID check. Well, there was just a very short, what we call buffer area that led up to those gate guards that were checking the IDs. And, people sometimes are like sheep. They just want to follow the car in front of them. And that's kind of what was happening. And so, the guy that was in charge of this process at the base, he realized that. And so he had this big sign printed up that said, 2 lanes ahead, pick one. And I thought, well, maybe that'll fix it. But it really didn't. I mean, other than it, I like the sign, but it didn't really do much because people were still, acting like sheep and following that other person. And so one of those gate guards that was checking IDs was often what we call starving. The constraint was starving because it didn't have anything to work on. And again, keep in mind that your constraint controls your entire output. And so through a coordinated project with the base and the city, et cetera, they came out with a solution, which was to create an additional buffer. So what they did was they were able to restripe some pavement, et cetera. And now they have this buffer area so that even if a lot of people followed the car, that there was enough time and enough space that those lanes would eventually fill up and that constraint would never starve. But again, going back to the 5 focusing steps, your constraint sometimes moves. And so that's kind of what happened in this situation where once the 2 lanes of vehicles got through the gate guards and combined back down into 1 lane, then it was a constraint again. So again, you would have to work through the process one more time and see if you could work that out. So some best practices: determine the goal. What is the goal for your organization? Once you have your goal, 5 focusing steps. If you're not meeting your goal, to determine where your constraint might be in your process and to resolve that. And then to continue doing that or repeating that process until you are actually able to meet your goal. And then again, just like we spoke to within Lean, you want to make sure that you have some sort of control plan in place to make sure your process or your improvements that you made stay in place. Some industry leaders here for you. Okay, another test. Theory of constraints is A, a new way of getting people to work harder. B, strengthening the weakest link or the constraint system. C, a fancy scheduling tool meant to confuse workers. Or D, adding extra inspections to improve quality. B. It can't be B twice in a row, can it? Yeah, I do that when I go to Vegas on the roulette wheel, but got to be red. Got to be red. But then it's green. I'm like, damn. Okay, good. So it was B. All right, last but not least, we have Six Sigma. And I don't want to frighten anybody here on a Friday afternoon. So hopefully we'll just hit the wave tops on this. And, we're not going to be calculating standard deviation or anything this afternoon. Unless you want to, I'll stay afterwards. But Six Sigma in a nutshell is basically, we want to make sure that we're disciplined with it, but also using, it's a data-driven approach where we're looking at eliminating defects within our process and driving towards a quality standard of 6 sigma, which is 6 standard deviations between our mean and our specification limits. And I'll show you a graph that kind of explains that here in just a minute. But it's a way to describe the quality of our process and how well we're doing. We wanted the focus of Six Sigma is to reduce the variation, because variation is bad if we want to have a process that's repeatable and predictable. So again, it utilizes standard deviation, which is mathematically calculated from your process. And that's at the heart of statistical process controller at what we call SPC. So here's what I was talking about before. So everybody's seen this before? If you're maybe back in college. And so if you have a Six Sigma process, that means that you have 6 standard deviations. Again, those are mathematically calculated from your process between your mean, which is the bar in the middle, or your average, and your specification limit. You have a lower specification limit and you have an upper specification limit. And depending on your process, they can be anything from I want it to be 2 and 6 hours, or I want it to be a length of between 2 and 6 feet, whatever the case may be. Those could be your specification limits. So if you have a Six Sigma process, again, you have 6 standard deviations on each side of your mean, between your mean and your upper and lower specification limit. And it's equivalent to what we call 3.4 DPMO, or defects per million opportunities. And we'll see kind of what that looks like here, I think, on the next slide. One thing to note is that some people sometimes get confused with control limits and specification limits. Specification limits are determined by our customers, and then control limits are determined by our process. So again, the specification limits are determined by our customer, and then control limits are determined by our process. So Six Sigma, again, the focus of that is to reduce the variation, and then thereby reducing the number of defects in our process so that they become statistically insignificant. What this is meant to represent is when you're looking at your process, the preventing mistakes before they happen or before they get to the point where they're defects. It's a lot cheaper to do that before they happen, but as you go along the process, if you catch it during the process, at the end of the process, or after the product has been released, then it's going to cost you a lot more money, whether it's resources such as dollars, whether it's time, et cetera. So what we want to do is we want to be able to design our process and make sure that our process stays in statistical control so that we don't have to, so it never gets to the point where a defect is discovered after it's released. How was it started? Developed by Bill Smith and Bob Galvin from Motorola back in 1986. So it's been around about a little over 30 years. Jack Welch, if anybody remembers who that gentleman is, from General Electric, was an early adopter. Made it part of his business strategy in 1995, required a good portion of his staff to be Greenbelt trained. And then I just threw up a book here that, in case you're interested or want a handy, kind of easy to follow reference from Michael George, is the Lean Six Sigma Pocket Toolbook, but it breaks down there's a multitude of tools within Lean Six Sigma or within Six Sigma, and this basically breaks them all down in a nutshell so that you don't have to memorize all those. Okay, so we talked about 3.4 defects per million opportunities a minute ago. Again, that would be considered best in class, or Six Sigma is best in class. Kind of to give you an example of what that might look like compared to how most people perform, or what the average is of 3 Sigma, where most companies operate, somewhere between 3 and 4 Sigma. You see up here on the screen. So if anybody out there is about to have a baby, and you go to a 3 Sigma hospital, then about greater than 40,500 newborn babies are dropped in hospitals each year. Whereas a 6 Sigma hospital would be 3 newborn babies dropped in hospitals in 100 years, or if that process was at a 6 Sigma level. Drinking water, there's certain places where you probably always want to have a 6 Sigma process. There's probably some where the view isn't worth the climb, or the cost to achieve that isn't worth it. So again, Six Sigma is going to be the 3.4 DPMO, or defects per million opportunities, and 3 Sigma is 2.3 defects per 100 opportunities. So again, a huge disparity or difference between those two numbers. Okay, so some components of Six Sigma. Everything we do in CPI, for the most part, is about the customer. Again, the customer is the one that determines quality, but they also determine what their requirements are, right? What their wants, their needs, their expectations, and we need to be able to design our processes or improve our processes to deliver those wants, needs, and expectations. I always like to throw in requirements, because in our business, for most of us, we're mission funded to do certain things or to provide a certain level of service. So a lot of times it boils down to requirements, not only for the customer, but perhaps voice of the business as well. Those requirements that the business has to meet. We need to make sure our process is able to deliver those. Everything we do is a process. All processes have variation. It's just kind of the nature of the universe. We have 2 different types of variation. We have common cause, which is going to be always inherent in your process, or it could be special cause, where it's assignable to some sort of event or actual cause. So if you think about your commute to work in the morning, if you leave your house at 7 o'clock every day, you don't always get to work at 7:30, right? Some of those reasons might be traffic, might be the stoplights, et cetera. So that's probably going to be common cause variation. Whereas if the metro's closed for a week, or the yellow line's closed for a week, that's probably going to be special cause. Or if there's an accident. Special cause, we're usually able to track that down to some sort of event, and then we try to prevent that from occurring again. Maybe we never ride the metro again. Maybe we fly instead of drive so we don't get in an accident. At the bottom of the slide there, on slide 38, you see some sources of variation. It can come from all over. But we have something called the 6 M's, which are man, method, machine, materials, measurement, Mother Nature. Those are all inputs to your process as well. If you think of any other M's, let me know. But those probably cover almost everything that goes into your process. And so if you have something that goes into your process, that's a source of variation, right? So some of the principles of Six Sigma are that we want to figure out what that special cause variation is, and we want to isolate it and prevent it from happening again. We want to figure out or get to what we call the root cause of the problem. Once we have that done, we can reduce our common cause variation by improving or changing our process. So maybe you take a different way to work, maybe you leave it at a different time, whatever the case may be. And we should all be able to anticipate this variation and design our processes to deal with that, or to expect that that's going to occur. If we only have common cause variation in our process, it's said to be stable and predictable, and that's what we want, right? We want to be able to make predictions based on that process. What you see up here is an example of a control chart, and again, that's the basis of Six Sigma and statistical process control is that you use the control chart in order to be able to monitor your process and make sure that your process stays in what we call in control. And so again, you have it basically starts off with what we call a run chart where you're just plotting your data. So maybe your first item came in at 100.5 there. Your second item came in at 102.5. That could be minutes, it could be dollars, it could be time, whatever the case may be. And then you calculate your control limits, again, statistically based on your standard deviation. You go up 3 from your mean or down 3 from your mean, and those are your upper and lower control limits. And you want to make sure, for the most part, your process stays within those control limits. If you have a point like you see there where your process is out of the control limits, it looks like on your fifth shot or your fifth item, then you probably have something going on in your process and you need to stop, take a look at it, and bring it back into control. So Six Sigma, how to do it? Again, so if we have a process that has a normal distribution or has that bell curve that we talked about, then we know certain things about it. We know that a certain number of our data points are going to fall under our curve there. Again, probably a little bit heavy for a Friday afternoon before Christmas, but the main takeaway is that if we know how our process is going to perform, then we can use that to our advantage to start making predictions in the future. With Six Sigma, we follow a roadmap called DMAIC, which is our problem-solving framework where we define the problem, measure it, analyze it, improve it, and then control it. Just a couple real quick best practices on Six Sigma. You want to make sure that when you're looking at your process that very little of your process variation is introduced from your measurement system. We call that, and you would want to do something called a measurement system analysis. And probably the biggest advice I can give to anybody is that common sense goes a long way, when you're looking at your process, not only with lean, theory, constraints, but Six Sigma as well. If it doesn't seem right to you, then it probably isn't, and you would need to take a little bit deeper dive on that. Some industry leaders for Six Sigma up there, and our last test of the day. So Six Sigma is what? Pick one. A new way of using metrics to blame workers, a war on variation, complicated statistics meant to confuse workers, adding extra inspections to improve quality. Yes, yeah, B again, good. So it's a war on variation, right? We're trying to reduce the variation in our process because we want a process that's predictable. Okay, so in summary, this slide, I'll let you guys look at this as your time permits, but basically just shows you some of the achievements that we've made within the DoD and Marine Corps. Whether it's inspections, whether it's, the check-in, check-out process and reducing the cycle time, it applies to pretty much any process you would have within your organization, whether it's reducing the need for manning. These are proven tools and methodologies that if applied properly and with some a little bit of rigor and discipline can provide some very substantial results for your organization. So again, lean is about removing the waste from our process. If we do that, it improves our cycle time and it reduces the cost. Theory constraints about reducing the constraints or mitigating those constraints, but very similar outcomes of improved process throughput. So we're getting things through faster and it's reducing the cost of that process as well. And then Six Sigma, statistically based on our statistical process control, and we're looking at trying to reduce the variation and therefore the defects within our process so that it is reliable and predictable. Okay, we're probably out of time for questions, but anybody have any questions? Why me?
There are a couple questions from online, but in the room, is there anyone that has any questions? Please use your microphone if you do have a question. So one of the questions we had from online was, how does Lean Six Sigma compare to Deming's total quality management?
So if you flip to the backup slides, there's a kind of there's a big arrow that shows the progression of CPI or process improvement within the Marine Corps. But it starts off at the lower end of the arrow. It starts off with TQL, TQM. I think a lot of the tools, again, some of these tools have been around for quite some time. Lean going way back to the 1900s. A lot of them are just packaged differently, maybe with more of a TQL, TQM. From what I really wasn't around at that time, but it was more of a cultural way that they enacted it. So, it kind of died a natural death early on. And so with CPI, they're trying to do a little bit differently so that we have self-sustainment within the Marine Corps, and so that it changes the culture. But as you can imagine, it's easier said than done to change the culture, of a lot of organizations, let alone one that's been around for, hundreds and hundreds of years and, steeped in tradition like the Marine Corps. So, we're still getting to that cultural institutionalization that you see out there at 2015. We were supposed to have gotten there 3 years ago, but I'm not sure we're quite there yet. But very similar methodologies, tools probably very similar, approaches very similar. It's just, for whatever reason, one, that one kind of died along with the dinosaurs.
We have one other question online. For theory of constraint, how do you identify the constraint if the goal is simply unrealistic?
Well, you're still going to you still identify the constraint the same way. It's going to be, if you walk around, whether it's an office, whether it's a production area, it's still going to be that area that has the most, what we call work in process. So you're visually going to look for that stuff, whether it's the person that has the most record books in their inbox, whether it's the machine that has the most work sitting in front of it. So you can run your numbers, but that's probably the easiest way to take a look at it, is to visually look for that within your organization or within your process and see, where is the most backup occurring. And that's usually going to be your constraint.
Thanks, everyone. So I just want to, do you want to show the resources really quick?
Yeah, so there's a whole bunch of resources that we put in the slide deck, and then an exercise as well, but we'll touch on the exercise kind of as a follow-up. But, maybe just start taking a look at, your processes, and, from here, starting today, you'll maybe look at things a little bit differently. You'll start seeing waste. You'll start seeing, Tim Would You everywhere you go. You start dreaming about it. You'll start seeing constraints. You'll start seeing where that WIP is piling up, where you have defects or poor quality, whether it's at home, whether it's at work, at school, or other. But maybe, take some time to think about those. And, while you're standing in line at the grocery store, you get behind the constraint, and we'll come out with a data call and see what, ask maybe you guys to submit some of those. So some of the resources, again, one thing I just wanted to point out real quick on slide 55, this is directly relatable to what you guys, to the previous presentation you had last month, I believe it was. When you're talking about the ECQs, the core qualifications for SES, but it's directly related to results-driven, process and quality improvement, and then program evaluation. So again, for senior executives are looked to have this sort of thing within their skill set. And again, so the resources start on slide 56, Federal Improvement Team. I found out about this program here through the listservs. So again, those are great sources of or resources that are available to you. There's the PIC, which is the Performance Improvement Council, through GSA, and then just a whole host of other ones. But I'll make sure that my contact information gets sent out as well. So if anybody has any follow-up questions, they are more than welcome to send those to me, and I'm more than happy to respond. And my apologies for going slightly over today, but a lot of information in a short period of time. So with that, I wish everybody a very Merry Christmas and a Happy New Year, and thank you for your time today.
Thank you so much, Michael.